What does the biochemistry of longevity look like? In an earlier video, we took a look at blood test data from the Centenarian study, which included more than 1,700 people that had a median age of 100 years old. So in that video, we identified what was good in terms of biomarkers that were youthful and were associated with a low all-cause mortality risk, and correspondingly, biomarkers that were bad. But what about the biochemistry of longevity in other geographical regions? So with that in mind, in today's video, we're going to take a look at blood test data from for Italian centenarians. And that's what we can see here. So first, identifying some terms. So in this study, there were 120 quote-unquote healthy centenarians, and I'll explain that more in a minute. So in terms of centenarians, this was heavily weighted towards more women than men, 100 women and only 20 men. And this is pretty common in centenarian studies, as far more women reach 100 years old than men. So in terms of healthy centenarians, what was that defined as? So these were centenarians that were free of acute or chronic illness, and more specifically, they didn't have Alzheimer's disease, metabolic diseases, cardiovascular disease, stroke, cancer, or any infectious disease, active infection. All right, so what about the data? So in this video, we're going to identify what was good, what was leaning towards not good, and what was just outright not good or even bad. And note that there's going to be a lot of data in this video, so there'll be timestamps in the video's description for each biomarker. So if you don't want to go through the whole video, you can just go through the video's description and click on each individual biomarker for the ones that you may be interested in. All right, starting off from the top, let's take a look at what was good and first on the list is glucose. So let's put this data into perspective with aging-related changes and all-cause mortality risk. So first, it should be pretty clear to everyone, glucose increases during aging, with values in the mid-80s in youth that increase to more than 100 in both men in green and women in red, as shown there. And this is data from a study that included about 12.5 million people. So putting the centenarian blood test, a blood glucose level of 84 into perspective, this would be a very youthful value. So what about all-cause mortality risk? So there's a similar story here. And using data from the same study, we can see all-cause mortality risk there, and it's a J-shaped curve, which means that lowest risk for all-cause mortality was in the 80 to 94 milligram per deciliter range. And then all-cause mortality risk increases for glucose levels below 80 and also higher than 95. So when we put the Centenarian 84 into perspective, we can see it's right at the bottom of that curve, so lowest all-cause mortality risk based on the Centenarian glucose data. So in terms of what's good, these centenarians have youthful and healthy levels of glucose. So next up is HDL. And so let's put this data into perspective. How does HDL change during aging? And we can see that data here. So HDL peaks in youth with values of around 56 for men and around 65 for women in the 20s, early 20s. And then the HDL declines pretty steadily during aging for women, such that 88-year-olds, the high end of the age range in this study, have values in the 50s. Now for men, the decline for HDL is more steep into the 30s, after which it stabilizes in the low 50s for the duration of the lifespan, or at least until 88 in this study. So when putting the centenarian data of 57 milligrams per deciliter into perspective, for women, this would be what you would expect to see, or an average value, what you'd expect to see for someone approaching 60. And for men, this is higher than the peak of around 56 in youth. So from this, we can conclude that HDL for these centenarians is youthful. So what about all-cause mortality risk? And we can see that data here. And again, this is from a study of 15.9 million people, and all of these studies will be also in the video's description. So when looking at all-cause mortality risk and putting the centenarian 57 milligrams per deciliter into this chart, we can see that it's right at the bottom of mortality risk, so it's at the lowest all-cause mortality risk. So in terms of what's good, we can see that these centenarians have both youthful and healthy levels of HDL. All right, next up are triglycerides. So starting with all-cause mortality data, and this is a meta-analysis of 61 studies, lowest all-cause mortality risk for triglycerides is around 90 milligrams per deciliter or 1 millimolar. Now, when you go higher than 1 millimolar, though, as shown by the red arrow, all-cause mortality risk increases as triglycerides increase up to 3.5 millimolar in this study. So that would be around 300 milligrams per deciliter. So putting the centenarian 106 milligrams per deciliter into perspective, we can see that it's relatively close to the lowest all-cause mortality risk. It's not at the lowest risk, 90 milligrams per deciliter or 1 millimolar, but it's not too far away from it. So in terms of what's good, these centenarians have relatively healthy levels of triglycerides, at least in terms of all-cause mortality risk. But we can put this data into perspective in a different way. So relatively low triglycerides may also be a hallmark of longevity. And this is data from 13 separate studies that looked at triglyceride levels in people that were 100 years old or older, as shown here. And as you can see by their triglyceride levels, in 11 of these 13 studies, triglycerides were less than 110 milligrams per deciliter, or around 1.2 millimolar. So that's why, based on this data, relatively low triglycerides may be a hallmark of longevity. All right, next up are red blood cells. So red blood cells decline during aging, as shown here, with values of about 4.8 in men, green line, and around 4.3 for women in youth, that then decline to about 3.9 in 95-year-olds. So putting the Centenarian data of 4.24 onto this plot, we can see that these red blood cells are about 30 to 80 years younger than expected based on a 100-year-old chronological age. So the Centenarians are off to a good start in terms of having relatively youthful red blood cell levels. Now, hemoglobin is found within red blood cells. So let's take a look at that data. And looking at all-cause mortality data, first starting with men. So in this study, the referent was defined as 14 to 14.9. In terms of the Centenarian data, they had 12.53 grams per deciliter. And as you can see, that men that had hemoglobin levels that were less than 13 in this study, that was significantly associated with an increased all-cause mortality risk. So any of the men in the Italian Centenarian study that had hemoglobin levels of 12.53 would have an increased all-cause mortality risk. All right, what about data for women? And note that, again, this Italian Centenarian study was predominantly women. 5 out of every 6 people or centenarians were women in this study. So when compared with the reference, in this case, which was 12 to 12.9, increased all-cause mortality risk for women was only present when hemoglobin was less than 11. So in this situation, the hemoglobin levels in the Italian Centenarian study were 12.53, which would put these women at lowest all-cause mortality risk. So in terms of what's good, these centenarians have relatively youthful and healthy levels of hemoglobin for women, and youthful red blood cells, but unhealthy hemoglobin levels for men with an increased all-cause mortality risk. All right, next up are platelets. So platelets decline during aging for both men and women. And so going from the age range from 20 all the way up to 100 for both men and women in this study, we can see that platelet levels start off at about 230 in men and decline to less than 210 as they get close to about 100 years old. Similarly, for women, platelet levels start off a little higher, around 260, that then decline to 240 as these women in this study approach 100 years old. So when considering that the platelets in the Italian Centenarian study were 212, that would be about 20 years younger than expected for the men, but even older than expected for the women. So what about all-cause mortality risk? That can help to add perspective to the age-related data. And in this study of about 130,000 people, when looking at all-cause mortality, 200 to 300 platelets was defined as the referent, as shown there, with the relative risk of 1. But then platelet levels that were less than 200 and that were greater than 300 had a significantly increased risk for all-cause mortality. So from this, we can conclude that 200 to 300 platelets is associated with maximally reduced all-cause mortality risk. So in terms of what's good, although these centenarians have relatively aged levels of platelets, these are healthy levels as it's associated with lowest all-cause mortality risk. All right, next up is uric acid. So how does uric acid change during aging? And note that there are very few studies on how uric acid changes during aging. And if anyone's come across larger studies, I'm going to show data from that included about 80,000 people. If anyone's come across larger studies than that, please post it in the comments. So starting with the data for men, this is about 50,000 men. First, they looked at men for each individual age group. So 20-year-olds, 30-year-olds, 40-year-olds, all the way up to 60-year-olds. And then these people came back and provided subsequent blood tests, so it was evaluated longitudinally. And when evaluated longitudinally, uric acid levels increase for each respective age group, as shown there for the men. But note that uric acid, UA, was higher cross-sectionally in young when compared with old. So we can see that the young people in this study had uric acid levels of about 355, whereas the 60-year-olds had values that were lower, of around 340. And if we would put the centenarian uric acid levels onto this plot, this would be even further reduced with a value of 333 micromolar. So from this, we can conclude that at least for men in this study, uric acid levels were indicative of aged. So what about the women? Now, this is data from the same study, about 30,000 women, and it's a little bit more consistent and clear. So after 40 years old, we can see that regardless of the age birth cohort or the age when uric acid levels were evaluated, whether in 20-year-olds or 60-year-olds, we can see that uric acid levels consistently increase during aging for women. So if we're going to plot the uric acid levels for women on this plot, we would see that it would be even higher than the top, which was 300 micromolar. So again, from this we can conclude that uric acid levels in the Italian centenarians was aged, or indicative of aged levels. All right, what about all-cause mortality risk? So that's what we're looking at here, all-cause mortality risk on the y-axis plotted against the concentration of uric acid on the x. Now, lowest all-cause mortality risk, as shown there at the bottom of the curve, was present at a concentration of 303 micromolar. And note that the centenarians, the Italian centenarians, had an average value of 333 micromolar, which is very close to lowest all-cause mortality risk. So that's good news. So in terms of what's good, although these centenarians had aged levels of uric acid, not youthful, they had close to the lowest all-cause mortality risk based on their uric acid levels. All right, so now we're going to start to get into some data that trends towards not good and starts to look outright bad. All right, so first, AST. This is a mostly liver enzyme. Let's put that data into perspective by looking at all-cause mortality data. And in this study, it was 16.6 million people. So first, when looking at the referent, which was AST with a median value of 20, the centenarian, the Italian centenarian value of 23.3 will put them into Q3, which had a 5% significantly reduced all-cause mortality risk. So AST is actually good news in this situation. All right, so what about ALT? This is also a mostly liver enzyme marker. So what does the data for AST look like in terms of all-cause mortality risk? So using data from that same study, in this case, the referent was defined as, had a median value, of 15. And this is where we would find our Italian centenarians, as their average value was 13.4. But notice there's a red rectangle there, and that's because although the referent in most studies is usually lowest risk for all-cause mortality, in this study, actually Q2 and Q3, so relatively higher ALT, in this case 18 to 22, was associated with a significantly reduced all-cause mortality risk. So in this situation, the ALT of 13.4 for the Italian centenarians would actually be higher all-cause mortality risk when compared with values in the 18 to 22 range. So we've got one liver marker that's good, AST, and one liver marker that may be not good or suboptimal, ALT. So to break the tie or to add more insight, looking at the ratio between these two, the AST to ALT ratio with all-cause mortality risk may provide more insight. And that's what we can see here. So we're looking at survival on the y-axis, so all-cause mortality, and then this is up to about a 10-year follow-up after the baseline assessment of the AST to ALT ratio. So, and again, it's all-cause mortality or all-cause death as shown there. So in people that had a relatively low AST to ALT ratio, in this case their ratio was about 1.02, and a relatively high AST to ALT ratio, in this case was an average ratio of 1.83, when looking at survival, or again up to about 10 years after the initial assessment, we can see that people that had a relatively lower AST to ALT ratio had improved survival, as shown by the green line, when compared with the red line that had a higher AST to ALT ratio. So putting the centenarian data into perspective, so dividing AST by ALT, that yields a ratio of 1.745, which is much closer to being in the high AST to ALT ratio range versus the low, which had a value of 1.02. So in terms of what's good, although AST is good and ALT is suboptimal, AST to ALT, that ratio, is most definitely trending in the wrong direction. All right, next up, in terms of things that may be trending towards not good, was total cholesterol. So first, let's take a look at how total cholesterol, TC, changes during aging. And that's what we can see here. So total cholesterol is relatively low in youth, and it's found in youth, and then it increases during aging up until around the mid-50s for both men in green and women in red, and then it starts to decline afterwards up to 88 years on, or the maximum age range in this study of 12.8 million people, so it declines up to around 88. But what about older than 88? So if we're going to extrapolate based on how that trend after the mid-50s goes for total cholesterol, I don't think it's a far stretch to think that we could see even further reductions for total cholesterol for a 100-year-old. So in that case, low total cholesterol is found in youth, but it can also be found potentially in advanced age. So total cholesterol, age-related data for total cholesterol can't tell us anything about whether it's good or bad for the Italian centenarians and their value of 189 milligrams per deciliter. All right, so what about all-cause mortality risk? So this is data from the same study and looking at the 75 to 99-year-old age group, which is pretty close to centenarian status. So when putting the centenarian data, the Italian centenarian data of 189 into perspective, that's actually not too far from the lowest all-cause mortality risk of 220 to 229 in this study. But note, there are some sex-specific effects. So having a centenarian value in this study of 189 was not significantly associated with an increased all-cause mortality risk for men, but a 5% increased all-cause mortality risk for women. So in terms of what's good, we can't tell if total cholesterol is youthful or aged. And although there isn't an increased all-cause mortality risk for men, there is a small but significant increase all-cause mortality for women that would have a total cholesterol value of 189. All right, so next up are leukocytes or white blood cells, WBCs. And this is data from the Baltimore Longitudinal Study on Aging. So people were assessed at a baseline visit and then provided blood samples, and their mortality status was evaluated more than 40 years up after the initial baseline assessment. So in this study, we can look at median survival. This is the 50% survival, the time when half the population has died and half is still alive. And we can see that the longest life expectancy based on white blood cells in this study was for people that had white blood cells in the 3.5 to 6 range. In this case, they lived 37 years after the initial baseline assessment. Now, shorter life expectancies were found for people that had white blood cells in the 6 to 10 range, and even shorter for people that had greater than 10 for white blood cells. But I should note that shortest life expectancy was found for people that had less than 3.5 for their white blood cell counts. So if we're going to put the Italian centenarian data into perspective, that would put them in the 6 to 10 white blood cell range, which isn't optimal, which isn't in the 3.5 to 6. But note that how much, 6.18 isn't that far from, being within that, 6 range. It's close. So in terms of what's good, white blood cells are just outside the optimal range of 3.5 to 6. So this isn't a terrible marker, but it could be a little bit better. Also note that how white blood cells change during aging isn't a homogeneous change. So white blood cells are comprised of neutrophils, primarily neutrophils, lymphocytes, and monocytes. Neutrophils and lymphocytes increase during aging, whereas lymphocytes decline during aging. So unfortunately, in this study, they didn't present that additional data for each of these white blood cell differentials, but that would provide more context to how/whether 6.18 is good, or potentially bad for longevity. All right, next up is total protein. So total protein levels decline during aging, as shown there, with values of around 7.4 in both men and women that decline to around 6.6 to 6.8, depending on if it's men or women, as shown by the red arrow. So if we put the Italian centenarian data into perspective of 7.11 gram per deciliter, this is 35. These are values that are 35 to 45 years younger than expected based on chronological age. So if we stop there and only looked at total protein based on aging-related changes, we would miss the story because this is a superficial analysis. And that's because total proteins equal the sum of albumin and globulin. So we can take a further look at how albumin levels are and how globulin levels are in terms of aging and all-cause mortality risk, and then get a better evaluation of whether total protein levels for these centenarians is good, intermediate, or potentially bad. So let's start with the albumin levels as shown there, 38.4 grams per liter. So how do they change during aging? Well, they decline during aging as shown there. So we're looking at albumin levels on the y-axis plotted against age, in this case all the way up to 100 years. And we can see that but for both men and women, albumin levels decline during aging, with a peak in youth of around 46 for men and about 45 for women. So putting the Italian centenarian data into perspective as shown there, 38.4, note that these are centenarians, so this is a small improvement. This is about 8 years younger albumin than expected based on their chronological age. So it would seem that this is good data, but let's have a look at all-cause mortality data for albumin. And that's what's shown here. So all-cause mortality data for albumin on the y-axis plotted against the concentration of albumin on the x. So in this case, albumin, lowest all-cause mortality risk for albumin is 46 grams per liter, as shown there. So it's the bottom of the curve. And then if we're going to put the centenarian data, the Italian centenarian data into perspective, 38.4, we can see that there's a significantly increased all-cause mortality risk based on their albumin levels. So what about globulin? As I mentioned, total protein equals albumin plus globulin. So since we know total protein and albumin, we can rearrange this equation to calculate the globulin or the gamma gap concentration. And when we do that, we get a value of 32.7 grams per liter. Now, note that I can't calculate the standard deviation, but at least we've got a pretty close to an average value there, or what we'd expect the average value to be. So let's put the globulin level into perspective. And this is all-cause mortality data or survival probability on the y-axis, plotted against time after the baseline assessment of globulin. And this was about a 5-year follow-up in a study of 94-year-olds, which isn't too far from our centenarians in the current study. So there are two levels of globulin here. We're looking at a blue line, which had globulin levels that were less than 3.2, and a red line that had globulin levels that were greater than 3.2. So in terms of life expectancy or survival, we can see that people that had relatively lower levels of this gamma gap or lower globulins, so less than 3.2, had the longest life expectancy. And then people that had higher globulin levels or a higher gamma gap, more than 3.2, had a shorter, significantly shorter life expectancy. And if we put the Italian Centenarian data into perspective on this plot, they would be on the red line, as their globulin levels would be 3.27 grams per deciliter. So based on that data, these centenarians, the Italian centenarians, would have an increased all-cause mortality risk when compared with lower levels of globulin. So in terms of what's bad, these centenarians have aged and unhealthy levels, at least based on all-cause mortality risk, of albumin and unhealthy levels of globulin. All right, so we've got two more biomarkers. First up is creatinine. So creatinine levels increase during aging, as shown here, as you can see by the red line, and this age range is from 20 to 90-year-olds, around 90-year-olds. So the importance of creatinine is that it's used to estimate kidney function using eGFR as the marker of kidney function. So when using the creatinine value of 1.29 milligrams per deciliter and a 100-year-old age, we get an eGFR of 37 for men and 49 for women. So why is that important? That's because eGFR, as that metric of kidney function, declines during aging, as shown here. So youthful levels of eGFR, or again, as that metric of kidney function, are around 125 in youth, that decline towards 50 in people approaching 100 years old. So putting the centenarian eGFR data into perspective on this plot, we'd expect to see it somewhere there around 50 or even less, at least based on the data for men. So in terms of what's bad, we've got these centenarians, these Italian centenarians, have aged levels of creatinine and a relatively low or age expected levels of eGFR. All right, so last but not least is urea nitrogen or blood urea nitrogen, and these Italian centenarians had a level of 52 milligrams per deciliter. So let's put that data into perspective. So blood urea nitrogen increases during aging, and if you're familiar with the channel, you've seen this data many times. So blood urea nitrogen levels are relatively low in youth, with values of 11 and 13 in women and men, respectively, as shown there by the green rectangle, and then it increases to more than 20 milligrams per deciliter in people approaching 100 years. So putting the Italian centenarian data into perspective, it would be way off the chart, as the highest blood urea nitrogen value on this chart is 24 milligrams per deciliter. So it would be way off the chart, as I've indicated there. So what about all-cause mortality risk? So that's what we're looking at here. All-cause mortality risk on the y-axis, plotted against the concentration of blood urea nitrogen on the x. So lowest all-cause mortality risk in this study of more than 425,000 people was present when BUN was 14.7 milligrams per deciliter. As you can see, it's at the lowest. It's at the the bottom of that U-shaped curve. But then as blood urea nitrogen increases, especially during aging, you can see that there's that red line. There's a significant increase for all-cause mortality risk. And putting the centenarian data of 52 milligrams per deciliter onto this plot, again, it would be way off the chart, as the high end of the chart only goes up to 39 milligrams per deciliter for blood urea nitrogen. So in terms of what's bad, these centenarians had aged and unhealthy levels of blood urea nitrogen. All right, that's all for now. If you're interested in more about my attempts to biohack aging, check us out on Patreon. Thanks for watching. I hope that you enjoyed the video. Have a great day.